problem. It is x minus 4y equals 6 and x minus 6y equals 12. Okay, so here we go. What we're going to do is we're going to solve this for x and y, okay? And when we find x and y, what we're doing, we're finding x and y that will fit or make both of these linear equations true, okay? So what I'm able to do, if you notice, got to set up a little different now. I can manipulate both the problems here and then also our camera at the same time. I think that's going to work out pretty well. All right, so what I'm going to do here now is I'm going to go to Desmos, which we've used before, and I'm going to type in these two equations. We got x, bring this over here a little bit, reach for it, there we go. We got x minus 4y equals 6. Ooh, should not be 47, that should be y equals 6. And there you see the red line appearing across, okay? And then our second line is x minus 6y equals 12. And there we see another one. They're very similar, looks like, but we notice that there is an intersection. Okay, let me zoom in on it. And it looks like it's negative 6. Oh, yeah, negative 6 and 1, 2, 3. Negative 6, negative 3. Okay, so just to show you, it looks right there, graphing wise, that our answer is negative 6, negative 3. All right, well, we're going to find out. A little hard to read it on the graph there, but let's go ahead and do it a couple different ways. Okay, one of the ways to do it is elimination. Okay, we've talked about substitution before. Let's do elimination here. So elimination basically is this. Let me give you an example of what it is first. Wing it here and see if it works. If we have two true equations, if we have 5 plus 3 equals 8, and we have 20 minus 10 equals 10. Both of those are true, right? Now, watch what happens here. Both of those are true. And if we add these down, okay, if we add these down and we get 25, positive 3 and negative 10 is negative 7, right? 8 and 10 is 18. Look at that. 25 minus 7 is 18, and 18 equals 18. All right? So let me take it one more step further here. I'm going to take the same problem we just did. 5 plus 3 equals 8. 20 minus 10 equals 10. I hate to pat myself on the back here, hurt my shoulder, but I never seen an algebra teacher explain it this way, okay? So let's just look at this again, okay? So we have a true equation because it's 5 plus 3 does equal 8. And we have 20 minus 10 does equal 10. And we just added down. 5 plus 20, 25. 3 plus a negative 10 is negative 7. 8 plus 10 is 18. And 25 minus 7 is 18. And 18 equals 18. So we're going to take that same thing, which I think alone is pretty cool. But now let's say what we're going to do is eliminate something, because this is what we're going to try to do. We're going to try to eliminate one of the variables. So the idea is you got to get a number going vertically that has to become 0. In this case, we do it with a variable attached. But couldn't we do the same thing right here? We're going to take this 5 plus 3 equals 8, and we're going to multiply negative 4 by everything up there. Now, why negative 4? Because negative 4 times 5 is negative 20. So I'm just rewriting it down there, okay? Let me separate it here, okay? So this stuff up here is the original problem right here, okay? And then what I'm doing is dropping my pen all the way under there. That's what I'm doing. But I need that, so I'm going to go get it. Oops. All right. Not so easy for an old man to get back like that. I'm back. Okay. Here we go. So, here we go. So again, one more time. We did this. We added them vertically down. We got it. It continued to be a true statement. Two true equations continued to be true when we added them. So here it is again, but then we multiplied -4. I'm going to multiply by everything in the equation, especially both sides of the equation, because that way it should stay true. So let's see. -4 times +5 is -20. -4 times +3 is -12. All right. And here we go. -4 times +8 is -32. Now we add them. Now again, there's our elimination because it's a number plus its inverse, which is going to equal 0, right? 0, but 0 minus whatever this is going to be is still going to be the same number. So most math teachers, after they explained it, hopefully they have, will do that. Okay, now let's add now. -10 and -12 is -22 equals 32 negative and 10 positive. Signs are different. We subtract, and the sign of the bigger. And there we go. So just with elementary type numbers with no variables at all works. So now the idea is to apply that same principle to this. And again, this is the number that it looked like was the right answer. In fact, let me just do this before I get going on it. Let's go back to, we're still on Desmos. Okay. So what I'm going to do is go here, and I'm going to add that point in, -6, -3. -6, comma, -3. Now, I haven't done anything, but I'm thinking that's it. And yeah, if you see the green dot appear right here, right there where my arrow's going, that is at -6, -3. So now I'm going to show you that how in elimination we will get -6, -3. We're going to solve, in this case, we're going to solve for y first, and then when we get y, we're going to take the value of y and put it back in one of the two equations and solve for x. Okay, so here we go. In this case, elimination is the easiest because all we have to do is get the additive inverse of one of these two. Well, since these are both the same, they're both 1x. We don't see that one, right? We know why, because 1 times any number is that number. In this case, that number is x. But if we multiply -1 by the entire thing, again, both sides of the equation, right? And look what I can do on this one. I don't even have to rewrite it, because when you multiply a negative times any number, that sign will change, all right? So negative times a positive is a negative. Negative times a negative is a positive, and negative times a negative is a negative. All right. Other times you'll see this. Let me pull away for a second. I'm actually going to use my stickies. All right. The times you'll see this, what we just did there, let me write it exactly. If you would have seen it like this, I'm going to take the negative of x minus 6y equals 12. Right? Or just x minus 6y, opposite, -x, +6y, and we did it there too. Okay, that's basically what we do. That's how you'll see it a lot of times, is you'll see the negative outside of parenthesis. All right, and then you're distributing that negative sign, which you'll hear many math teachers just say, just change the sign, just change the sign. But I want you to understand why. We've actually, let me write it over here. Mrs. Moore, my junior high math teacher, says, write it over here. So we multiplied -1 times everything in there, and we already changed it. Okay, so now we have this. Well, guess what? Remember what we did over here? Remember this one here? When we got that one that's different, the 20, we could just add down, and that's what we do. So x minus x is 0, so that goes away. Again, that goes away, meaning it becomes 0. It's the additive inverse, and when the additive identity says 0 plus any number is that number, there's no reason to write the 0. Okay? All right. So that's what math teachers are talking about, saying we want this to drop. basically means that you want it to be adding or subtracting 0. Okay, now here we got negative 4y and positive 6y. Remember, we can only add common variables, okay? Only common variables. So if we go negative 4y plus 6y, signs are different. 6 minus 4 is 2, and the 6 is bigger, therefore the sign stays positive, and we don't write it when it's a positive and it's the first number, the leading number. Okay, here we go. Then we get 6 and negative 12. Again, they're different. 12 minus 6 is 6, and the 12 is bigger. Now we got this. All right, the next rule, just happens to be right here, is any number, this one. I saw them there and I needed them, right? Any number, no, third one. Any number divided by the same number is 1. Any number divided by the same number is 1. Can't say it enough that why we're doing these things. So any number, let's say it one more time, any number divided by the same number is 1. Well, there's 2, so if we divide by that same number, we get 1. And 1 times any number is that number. Very important. So what we do is we just multiply it like that, or divide by the same number, but we have to divide this side by the same number because it's an equality, and that's also 2. And negative 6 divided by 2, when the signs are different with multiplication or division, a negative and a positive will give us a negative answer, okay? And 6 divided by 2 is 3. So there we go. Y is negative 3. All right. So now if we go back to this original one, let me rewrite it. We're going to bring it down here. We say x minus 4y equals 6. So now we have to take what? Use my yellow highlighter again down here. You got to take this negative 3, right? And we have to plug it in wherever there's a y. Well, here's the y right here. So what we do is we take that negative 3 and put it there, which means we're going to multiply negative 4 by it. Okay? Here we go. So we go x minus 4 times negative 3, see the y, equals 6. So now we're going to solve for this x right here. Okay? Yeah, let's make x blue so we can see it nice and good. Here we go. There's blue right there. So we're solving for that x. All right. So here we go. Negative 4 times negative 3 is positive 12. No sign needed. All right. Plus 12, we do need it. I'm sorry. Equals 6. Now we take negative 12. We got to add the opposite. It goes away. We understand why. But we have to put negative 12 here. And 6 minus 12 is negative 6. So we get x. There's our x right there. Just bringing it down. Equals negative 6. So x equals negative 6, right? And y equals negative 3. And lo and behold, that's what we said way back from the beginning when we saw it on the graph. Okay? All right. So just for not to get confused with trying to find a new answer, I'm going to go to same problem now, okay? But I'm going to solve it a different way. Here was graphing how we did it on the graph. We found that intersection. This was what? This one was called elimination. I think I did a good job of explaining that, why that works by using some basic numbers. All right, so now we're going to take that same problem. There we go. Rewrite it again. We already know the answers. What was it? It was negative 6, negative 3. Here we go. Negative 6, negative 3, x and y. Okay, there's our answer. All right, and I'm going to rewrite it again. X minus 4y equals 6, and x minus 6y equals 12. Okay, so this case, I'm going to use what we call substitution. All right, there we go. Let me write it. So we're going to do substitution. All right. And what that means, we're going to substitute something, just like in sports. You put one in for another, somebody else. So what I'm going to do is make one of these two x equals. Really doesn't matter which one. They're both kind of nice here. So I'm going to go ahead and do the second one, and then I'm going to bring this first one down to use it in a second. All right, here we go. What am I saying? So we're going to take this bottom one and we're going to solve for x. So we got to add 6y, which is what? It's called the additive inverse, right? Got to get this terminology down. Additive inverse, right? So there it is. Additive inverse, which means we add the opposite to make it 0, right? That's what we've done. Now it's 0, and then we use the additive identity to let it go away, because any number, in this case, plus or minus 0, is that number. So these will just go away, and what does it leave? It just leaves x on this side, okay? And then we add it over here, though. So we've just rearranged this equation a little bit, all right? So there it is. All right. So now I'm going to rewrite it here. So now we got x equals 12 plus 6y. So that was the original one, but we solved for x. Okay. Now what we can do is we can take what x equals and plug it into the other one. So we're going to take whatever x equals, all right? Let me highlight to make sure it's clear. Here's x, and here's x. And this is what x equals. So whatever x equals, we can substitute for this x. All right, so let's go ahead and do that. All right, hopefully we got room here. Separate it with the red, not to get confused. Here we go. Okay, so here we go. Start up here to give us a little room. So right here, wherever x is, I'm putting this. So I get 12 plus 6y minus 4y equals 6. Again, here's the x. I took what x was equal to right here, just plugged it in and wrote it. Now we solve for y. Okay. Combine like terms. Positive 6y and negative 4y is positive 2y. All right, and we got to subtract 12 from this side to get it to drop, right? We understand why. Not just doing it without you understanding. But we got to do it to this side. And now we get 6 minus 12. The signs are different. Subtract sign of the bigger. All right. Any number divided by the same number is 1. There we go again. You'll see it a million times with me. Fundamentals of math. So we got to divide this by the same number. So we get 1. 1 times y is y. This side we get divided by 2, and then y equals negative 3, because negative 6 divided by positive 2 is negative 3. There we go. So our y, negative 3. Then we go back, just like we did before. We'll take this negative 3 now, because that's what y equals, right? We'll go back to the original now. We're going to plug in for that y right there. Okay. So here we go. I'll do it in red. So right here, we go x minus 4 times y. What does y equal? Y equals negative 3 equals 6. Here we go. X minus 4y equals 6. One more time. We took this one here. We had y equals negative 3, so we're substituting it for this y up here. Okay? Put it in red here. Here we go. Y. Okay. So here we go. X, negative 4 times negative 3 is positive 12. A negative times a negative is a positive. I've explained that in earlier sessions. You go back and watch why anytime, but I could explain it, but I'm not going to do it right here again. We'll do it later. Trust me, it does. It does work. And then we get equals 6. And we got to subtract 12. The additive inverse to get 0 goes away. And then we got to subtract 12 over here. So what do we get? X. 12 minus 6 is 6, and the sign that is bigger is negative. The signs are different. Here we go. Negative 6. So our point is, what's our point? We had it up top. Negative 6, negative 3. So that's 3 different ways now that we have identified how to find the solution of 2 lines, right? Here's substitution. We came up with negative 6, negative 3. All right. Here was elimination. We came up with what? Negative 6, negative 3. And then right here, right over here, see that? I put that negative 6, negative 3 in, and there it is right there where the points intersect. Now, just so you know, okay, so I can make this bigger so we can see it. It's going to mess up my calculator. And you just got to see this. See way up here? That's negative 6. A little hard to see. There it is, -6. If we drop straight down, it's to -3. Now, when you see these little squares, it's because they've broken the one hole down into 1, 2, 3, 4, 5 fifths. So anyways, if we just went to the regular size, I think if I make it like this, it does it. There it is right there. There we go. Exactly. No, that's actually halves is still at. So we'd have to go right there. So it's -6 and down -3. Okay, pretty good. So let's go from there. Now let's go back to some of these fundamentals of the necessary. We talked about that in the last couple sessions, but we're going to specifically focus in on solving the equations. And one of my favorite places to go is a place called Delta Math. And here we go, right there. And we get a problem right here. So what I'm going to do is I'm going to take this problem, I'm going to switch it back to the camera. We're going to go over the problem, and then we're going to submit our answer and see if it was correct. I remember one administrator once told me after seeing my class, that John, you should have the answer figured out ahead of time. You shouldn't figure it out. And I understood her point, but it's also very important to show the thinking process. And that's why I like using Delta Math. I can't know what the next problem is going to be in Delta Math. Therefore, we get to just move forward and solve for it. Okay, so as I write this down, you think about what you'd be doing on this, okay? -50 equals 4a minus 2. Okay, here we go. Let's do it. Here we go. I wrote it. -50 equals 4a minus 2. Now, of course, what did I do with all my little props here? There we go. My 3 rules. Here they are. These are my 3 rules to math, understanding all math. Any number divided by the same number is 1. Any number times 1 is the same number. And any number divided by any number divided by 1 is the same number. Now, what I'm going to do is I'm just going to go ahead and use my little stickies here so I don't have to write up on it and show you what they mean here. Okay? So, any number divided by the same number is 1. All right? Here we go. So, 3 divided by 3 is 1. Oh, yeah, that's pretty simple, right? But we're going to get more complex things, right? What if I said the number, what if I said, I'm falling all over the place here. What if I said the number was a fraction? What if I said the number was 1/3? What if I divided by 1/3? Well, that number's got to equal 1, right? Well, how do we do that? This is how we do it. So let me get a piece of paper here. So we got 1/3 divided by 1/3. 1/3 divided by 1/3. We talked about this a little bit in an earlier lesson, but the rule is keep, change, flip. All right? It's a little mnemonic device to help you remember what to do. I actually remember my oldest son's, now in 9th grade, his 5th grade teacher marking it wrong because he wrote keep, change, flip, even though I got it right. And I understood what she meant. She didn't want him to remember the saying and not understand why you do it, okay? All right. Well, the big picture is this. Get some more paper readily available here, okay? So let's do this. All right. So keep, change, flip with this. And the way I like to explain this is like this. If I said 20 times what number equals 4, right? 20 times what number equals 4, right? The first thing somebody always yells out when I do this in a classroom, they yell out 5. Well, I hope you can see that's not true, but just to make sure, we're going to put 20 times 5. No, that doesn't equal 4. That equals 100. But they're thinking, wait a second. They're thinking it's 20 divided by 5 equals 4. And that is a true statement. Yes, we'll confirm that. 20 divided by 5 equals 4. But these two numbers are different, okay? Those two numbers are different, although it's the same property. So if we go to that little saying, keep, change, flip, we keep the first number the same. All right, let's do that. Let's keep the first number the same right here, because we want to go from division to multiplication so that we know what number goes there. So when we change this to multiplication, because keep, change, flip is how to go from multiplication to division and division to multiplication. So the first one says, keep the first number the same. Let's keep it the same. Second, change the sign. Multiplication to division or division to multiplication. All right, so we got to change division to multiplication. Then it says, flip the fraction. Well, that second number, you say, wait a second, that's not a fraction. But again, kind of mentioned this before, but the more times we go over it, every whole number is a fraction, or at least you could write it as a fraction. So if we take 5, right, we have to divide it by 1. All right, that's one of our 3 rules. Let me go back to it. Here we go. Where is it? Any number divided by 1 is the same number. So if we take 5 and divide it by 1, now it's the same number. Still 5. So if we can write that number as a fraction, right, then we can flip that fraction. What does flip that fraction mean? It means take the numerator, the denominator, and make it the numerator, and take the numerator and make it the denominator. That's what we do. We make the denominator the numerator, and the numerator the denominator. All right? Now, same rules. We're going to keep going back to them. Any number divided by, no, that's not it. This one here. Any number divided by 1 is the same number. Okay, we just use that. Any number divided by 1 is the same number. So now we use it for 20, right? And now we have a fraction times a fraction. And that's what we want to have it as when we multiply fractions, because we multiply the top, or the numerator, times the numerator. We get 20, right? 20, and 1 times 5, 5. And there it is. That means 20 divided by 5, which is 4. So if I went back one step and I just covered up that 20, think here, if I just cover up that making 20 a fraction, what do we see? 20 times 1/5 equals 4. Well, there it was. So what went here? The answer is 1/5. Okay? We need to understand that, okay? Because with the overall understanding, okay, that any number divided by 1 is the same number. And here it is simply explained right here, right? We got 5 equal parts, and when you divide it into 1 equal group, well, how many are going to go in there? Well, 5, right? So any number divided by 1 is going to equal that number, 5, okay? So that's what we have to understand, because what we're going to do is take very simple concepts and we're going to apply higher level thinking to it, right? So, watch this. We're going to get to these problems in a second, but I just want to, all right, so if I said 2/5 times some number equals 20. What number is it? Right? So, when we're solving equations, any number divided by the same number is 1. Right? 2/5 divided by 2/5 is 1, but we also have to divide this one by 2/5. Okay? And you're like, that looks kind of weird, right? But really, in the reality, this is what it is. So any number divided by the same number is 1. You know what I'm going to do? I'm going to get that teachable moment here. Move my stuff. And I'm going to go on, leave this for a second, and I'm going to take this right here, 2/5 divided by 2/5. I'm going to go to my calculator online here. Let's see it. Here it is. All right. And 2/5 is, we put parentheses, 2 divided by 5 because that's 2/5. And we're going to divide by parentheses 2 divided by 5. But there's other calculators that actually have a fraction, but that's 2/5 divided by 2/5. And if that doesn't equal 1, I'm going to send you $100,000 in the mail. Holy cow, it equals 1. What do you know? So any number divided by the same number is 1. Very simple when we see it as 3 divided by 3 or 5 divided by 5 like I showed you, okay? But we need to be able to apply it. So now, since we know that, we just said 2/5 divided by 2/5 is 1. So there's our 1 times x, and any number times 1 is that number. Multiplication property of identity, all right? So what do we get here? So now we got to divide 20 by 2/5. Well, 20, we can make it a fraction by dividing it by 1. Where's my rules? They're always here. I'm going to keep showing them till they're so ingrained in you, right? All right, so what are we doing? Any number divided by 1. Oh, it's right under it. There it is. Any number divided by 1 is the same number. Okay, got to show that. I'm going to leave them right there so I don't lose them. All right, so we took this 20, right? Let's just back up. We had 2/5. The original problem was 2/5 x equals 20. So we divide both sides by 2/5 right here. Any number divided by itself is 1, right here, 1x equals, now we got to take this 20 and divide it by 2/5. So I put 20 first, right? And in here, I'm going to use pencil here for good reason in a second. Divided by 2/5. I wrote both of them in pencil because what was our rule? I know you know it. I know you know it. Keep, change, flip. Keep the first number the same, which we did. Change the sign and flip that fraction. So now that fraction becomes 5 over 2 rather than 2 over 5. And guess what? 20 times 5, 100. 100 divided by 2. Oh, move it over. 20 times 5, 100. 1 times 2, 2. 100 divided by 2 is 50. All right? So, here we go. Let's put this original problem, right, in the calculator. Well, I'm not going to be able to put x there. But what I'm going to do is I'm going to do this. 20 divided by 2/5. And I should get 50. So let's go ahead and do that. Let's see what we get here. Go back to the calculator. 20 divided by 2/5 right here. We'll do 20 because that's what x equals. Here we go. Here we go. We're going to clear it. And we're going to go 20 divided by parentheses 2 divided by 5. God, I hope it's 50. Oh my God, look at that. Okay. So a calculator is doing what you can do, but I want you to understand it. Okay. So all of a sudden, some of these problems we're going to solve for on Delta Math here, we're going to have to do that. Okay. Anyways, let's just go ahead and solve these problems. I originally wrote that problem and got distracted there, but it was good distraction because it was teachable moments. Okay, put my 3 rules here not far away. Put that over there because I'm done with it. Okay, so here we go. So I wrote this. Oh, you're not seeing what I'm seeing because we're not. There we go. Look how quick I do that now. All right. Okay, so here we go. So we have 50 equals 4a minus 2. All right, well, the key on this is, let's just talk about some of these words. Isolate, right? Got to hide in the corner by himself. Go stick your nose in the corner, right? And I'm glad they don't do that anymore. That's not right. So anyways, but to isolate means to make by itself. So what do we have to isolate? We have to isolate the variable. Here's our variable A, okay? We got to get that by itself. But we notice that it's attached to a number in front of it, and that's called the coefficient. That's attached until we unattach it, really, by making the coefficient 1, right? And we do it to both sides of an equation. We'll see that in a minute. But the bottom line is we got to get this 4A by itself. So we got to get this to kind of, you hear math teachers say, get it to drop. Well, what does that mean? That means we have to deal with what we call the additive identity, or the additive inverse, let's say. Because it's really additive inverse / additive identity. I'll show you why. And this is why it's both. So what we do is we add the opposite number. All right? So if we have -2, we add 2, right? So if I owed you $2, it was -2, and then I gave you $2, we'd be even, 0, right? But that's it. So anytime the signs are different, we subtract. 2 minus 2 is 0. But when we add or subtract 0 to any number, it just is that number. So what you will see math teachers do say, okay, that cancels or that goes away. But don't take a moment, at least initially, maybe enough times, is to say, well, that's the identity property of addition. All right, that's the addition identity. Is any number plus 0 is that number. All right. So what happens is we get 4A. But notice here, right? I'm going to go ahead and highlight it right there. We added 2, right? Well, guess what? Here's our equal sign. I'll make it in brown. Right here, we got an equal sign, right? So whatever you do to one side of an equal sign and this side, the right side, we got to also do it to the left side to balance it out. We got to balance it out. So what we have to do is we have to subtract 2 over here as well. So now we get this. We have 2 numbers where the sign is the same. So we add them and we keep the sign. All right, so if we bring that down, what do we got? We got -52 equals 4A. And then here's the scary thought about teaching live without knowing the answer. Ouch. Let's see if I can get it right here, because when I put it in there, if I don't get a red check or green check, that means I got it wrong. But let's see. If I copied the problem right, it's going to be right. If I copied this problem right, which was -50 equals 4A minus 2. Why don't I just go back and double check real quick right here, aren't we? Love the way I can go back and forth, but where's delta? -50 equals 4A minus 2. Okay, I'm confident. I think I'm going to get this right. No, not that one. Where am I? Camera. Here we go. Okay. So I think I'm going to be right. Now, so here's the rule now. Any number divided by the same number is 1. Okay? And again, I kind of got into a fraction a little bit there. But basically, remember when I did that? 1/3 divided by 1/3? But in this case, it's 4. So any number divided by the same number is 1. And then we just attach a variable there. Because we want to know what 1A equals. Just an A. What is the value of A? 1A. Not the value of 4A's. So here, we're going to divide by 4. 4 divided by 4 is 1. And 1 times A, all right, any number times 1 is the same number, same rule. So 1 times A, we don't see the 1 there. We don't see a coefficient when there's only 1, because 1 times any number, we know what that number is. We don't have to guess. Doesn't matter what it is, it's not going to change because of the coefficient. Okay, so here we go. But because we divided by 4 over here, we got to divide by 4 over here, right? So should I do it longhand or do it with the calculator? Let's go ahead and do it longhand just this one time. A negative divided by a positive is a negative. Talked about that earlier. You can go back and watch that lesson if you want. I proved it. Why a negative times a positive is a negative, and a positive times a negative is a negative, and division is the same as multiplication. So now we just got to go 52 divided by 4. 4 goes into 5 one time. 1 times 4 is 4. We subtract. We get 1. We bring down that 2. How many times does 4 go into 12? 3 times. Multiply 12. And when we get a remainder of 0, right? We get a remainder of 0. That means we're good. But sometimes you're going to have to, most of the time now in advanced math, you're going to have to write the remainder as a fraction. Well, if we took the remainder, 0 over 4, well, if we had 0 and we had to put it in 4 equal groups, how many would go in each one? 0. So if we're adding the remainder on, any number plus 0, same rule. So our answer should be 13. So we go back here, go to our delta math. Where are you? There we go. And we put in the number. Now we got to get the sign right. Got to get that sign right, okay? And our sign was negative, wasn't it? So yeah, negative 13. You're not seeing me right. Let me just put it here. Negative 13. Here we go. See, it was 13, but we knew it was negative, and here's our answer. So now, go back to delta math. I put negative 13, and hope I get a green check. Oh, I'm nervous. Ouch. What did I do wrong? Ow! Okay, I missed it. Beautiful. I love it. All right, what did I do wrong? Notice the number under negative 2. I got negative 2 here. I said I had to add 2, which I did to get 0, but I didn't add 2 over here. I subtracted 2. So I got to add 2 here. So now it's 2 signs are different. And it's negative 48. And then this becomes negative. Oh, look, you're not seeing me do it. Let me fix my stuff here. Ouch. All right, way over here. Here I did add 2, but what the mistake I made is I had negative 2 here and negative 52. See it? Something seemed weird about that. I knew I was making a mistake. I could feel it. All right. So this is the way that your instructor shows you that they make mistakes too. Right? But I got to take my time. That was my fault, of course. Who else's fault would it be, John? Okay. So 48 is here. And then let me just go, let's just use 48 divided by 4 here. I know it's 12, but let's do it anyways. So our answer is negative, and it's 48 divided by 4 is 12. So our answer is negative 12. Ouch. Ouch. Okay. At least I can figure out why I missed it, right? Here we go. Back to the problem. And that's what I love about that. Look at the bottom, negative 12. Should have had it. Oh, no. New, showed a question and new problem. Here we go. Ouch. Okay. So what do? They give me a tougher one now. But here was what I was talking about before, okay? Where you start getting fractions where you have to solve it. All right. So I'm going to write this problem down. It's b divided by 3 minus 45 equals negative 40. All right. Write my equal sign in the darker so we see it good. All right. So let's go back to the camera. I didn't say I was going to send you all $1,000, did I? I don't think I did. Anyways. Okay. So here we go. So here's the problem. And we got to find out what b is, right? So we got to isolate b. Now, what we need to understand, okay, is this right here, b over 3. If I said, what is the coefficient for b? It's actually, there's a 1 here that we don't see right here. That makes 1/3. So actually, 1/3 b is the same as b over 3, okay? Let me show you how that would be true. Because if I took 1/3, this means multiply, and I had to multiply by b, what would the denominator for b be? Somebody call it out. Any number divided by 1 is the same number. So the denominator would have to be 1. And if we multiply across, 1 times b is b, and 3 times 1 is 3. See the b over 3 here? Same thing. So this 1/3 b is actually how we're better off working with it. Okay? So as Wouldn't you know it? I didn't even know that problem was coming. Remember that one? In order to get any number divided by the same number is 1. Well, this is what we're going to have to do here in a second. Okay? So we got minus 45 equals minus 40. So first we got to isolate that. So we got to do the additive inverse of negative 45. We want it to become 0 because any number times 0 is the same. So to use some of the terms, we get that number to drop. Well, we actually get it to add it to make it 0, and then 0 plus that number is that same number. But both sides of the equal sign, right? So if we added 45 here, we've got to add 45 here, or else they don't stay equal. Now we have a positive 45 and a negative 40. That's two signs are different. We subtract. We look at what digit is bigger. 45 is bigger, so our answer is positive, so we don't put it. So now we're here. So now what do we got to do? Now, we understood. Let me get pink here so we don't get mixed up. All right? There we go. So, back in the day, right, 4x equals 8. We would divide both sides by 4. So now it's the same thing, except we're not dividing by 4. Whatever that coefficient is, we got to put it on the bottom. Well, there it is, divided by 1/3. Any number divided by the same number is 1, and 1 times that number is that number. So what do we have to do? We have to divide this side by 1/3. We got 5 divided by 1/3. So here we go. I know somebody's doing it. I hear you yelling it. I'll give you the first word. Keep. Keep. Keep, change, flip. Keep the first number the same. Change the sign from multiplication to division or division to multiplication and flip the fraction. So here we go. We're going right here. This is what we're doing. We're going 5 divided by 1/3. Make the keep the first number. We'll go ahead and just divide it by 1 to save a step. Change the sign, division to multiplication, and flip that fraction from 1/3 to 3/1. Multiply across 15 times 1 and 15. 15 divided by 1, we know that any number divided by 1 is the same number. See how these rules always come in? And that will equal 15. So our answer is going to be 15. I need redemption here. So I'm going to put 15 here. And I just know I'm going to get, I'm going to put 15. Make sure I got it right. 15. Oh, God. Let's see. Yes! Green check. If I was 0 for 2, I was going to get fired. Okay. So back to the camera. There it was. Right? So what do we have? We have 1/3 B equals 5. We divided both sides by 1/3. We got B equals 15. Of course, that's what we did right there. Divided this. This divided by this is 1. 1 times B is B. And we went 5 divided by 1/3. There it was right there. We got our answer of 15. All right. It's repetition. You know, I remember my dad, God rest his soul, passed away at 90 in 2019. And he was a coach, college All-American coach. And he used to say that he remembers this music teacher said, Demi, you know, music's not much different than sports. He goes, how so? He says, you know what? My kids don't get good at playing music by just doing it one time. You got to do it over and over and over, and then you get good at it. People say, oh, look how naturally talented they are. Well, there's natural talent, but it's practice. So, you know, just one quick little statement here that I want to make. As I'll never forget, I had this career day one time in 5th grade, and this African-American gentleman came in. The reason I mention that is because, you know, I just want him to be a role model for other African-American kids, okay? And that's why I mention it. You know, but for all kids, he's a role model, okay? But he came in, his daughter was in my class, and he was a vice president of a bank making over $200,000 a year. And then he opened his own consulting firm and was making near like $500,000 a year. And why do I mention this? Because it relates to what I was just saying. He said that one thing I learned very early was I can outwork other people. I can work harder than them. So if you get that in your mind, and why did I mention that? Because these are practice. If you want to get good at something, then you got to practice it. It's got to be more important than Snapchat or whatever you want to call it. It's more important than YouTube, unless they're my YouTube videos on math, and then that's where you go. All right, so let's move on. Here we go. Let's start it blank here. All right, let's go to Delta Math. I'm having a good time here. Okay, we got to go new problem. All right, here we go. All right, now as you're working through this, ideally, you can pause this video, try the problem yourself, see how I worked it out, and go see that I got a green check at the end, which I'm not missing another one tonight. That's it. I'm going to focus right now. Here we go. So I'm going to write this problem down. Negative 86 equals 10b. I'll write it in a different color so we can not get mixed up and make it look like a 6 plus 24. All right, let's move it over to the camera here. Here we go. There's our problem. All right, so we're solving for B. Solving for B. All right. So we got to isolate B. Got to get it by itself, right? So in order to keep this B by itself, we got to get this 24 to go away. How do we get it to go away? We add the opposite. That becomes 0, right? Then 0 plus any number is that number. So we're going to get 10b here because that becomes 0, right? So this now I'm going to start going a little faster like you see most math teachers do because you understand why. If not, go back to the beginning of this video and see why. Okay, but if we subtracted 24 here, we got to subtract 24 to the other side of the equal sign. Here's our equal sign, right? You can't do something to one side of an equal sign and not do it to the other side of the equal sign, or it's not equal, right? We both had $20 and I took 5 from one person. I better take 5 from the other or they're not going to have the same amount. If I multiply one person's by 4, then I better multiply the other person's by 4 or they won't have the equal amount, okay? So now we go our rules. We got to remember our rules. We're adding the same numbers with the same sign, right? We add and we keep the sign. So there we go. We got right here, draw a line here thick so you can see we're going to the next step. So we have negative 110 equals 10b. We don't want to know what 10b are. We want to know 1b. So any number, yeah, you got it. Where is it? Where is it? I keep changing flip. Here we go. I keep doing it. Any number divided by the same number as 1. Very important. All right. Because any number, 10, divided by the same number is 1. Right? And 1 times b, what is 1 times b? Any number times 1 is that number, just b. We're just going to write b. Okay. Here's our equal sign, but we got to do it to both sides. Got to stay equal. So we get 110 divided by 10, okay, equals, well, most importantly, we got to know we have a negative on top and a positive on the bottom makes it negative. So our answer is going to be negative. And then 110 divided by 10 is 11. All right. Now I could go through it, but I'm not going to do a division lesson right now. If you need to work on your division, work on it. So we're going to put negative 11 in Delta Math. Negative 11. Double check my work. I think I'm right. Green check. All right, on fire. What's great about this is you look down, see? It's exactly what we just did right there. So Delta Math is a great program. Undo addition by subtracting 24 by both sides. Undo multiplication by dividing both sides. So we say undo, or they say undo. I like to say using the new problem. Good. Ooh, look at this one. All right. Let me write this one down while you're looking at it. Figure out in your head what you got to do before we do it. All right. Let's see. Write it down. Negative 46 minus y divided by 4 equals negative 35. Okay. So I hope you're thinking, what's the first step? I hope you're thinking isolate the variable. There it is. Okay. So see our variable is y. Okay. In this case, it's negative y, but we got to keep that negative with it. So we got to do what? We got to add the opposite of negative 46. That's 0, and 0 minus that number is still going to be that negative number. So this becomes 0, which is why it goes away, but we got to add 46 on this side, right? Two numbers are different. We subtract. So really you would go 46 minus 35. Let me just do it right here. I guess I got room. 46 minus 35. That's 11. And the sign is positive is bigger. So we have 11 positive, and we get negative y over 4 equals 11. All right. Now, remember, just talked about it a second ago when we're doing the 1/3 thing. How do we get y over 4? We get that because we need the coefficient in front, okay? Remember, there's a 1 here you don't see, and there's our variable right there. Negative 1/4 y, right? Do it one more time, because why does that work? This is what we got. This is what I'm going to write here. Negative 1/4 y equals 11. But here, how did we get that? We took negative 1/4. This is multiplication times y over 1, any number divided by 1. 1 times y, or negative 1 times y is negative y, and 4 times 1 is 4. So there it is, negative y over 4. See it way up there? See it there? Okay, so this is where we're at, right here. Right here. Right here is what we got. So what do we got to do? We got to multiply any number divided by itself. So this is negative 1/4. We got to divide by negative 1/4 here. Now here we go. A negative divided by a negative is a positive. We already know a number divided by itself is going to be 1. 1y. There we go. 1y. Negative 1/4 divided by negative 1/4 is 1. So now in order to get this, we're going to have to do 11 divided by negative 1/4. Let me do it over here. 11 divided by negative 1/4. All right, I heard somebody yelled out. I hope you're anticipating what I'm reaching for here. What am I reaching for? Keep, change, flip. Because we're changing from division to multiplication. So we keep the first number, 11. In fact, we make it a fraction. Change the sign. Flip the fraction. All right? We could even put the negative 1 down here. It really doesn't matter. As long as one of the two are negative in a fraction, the fraction is negative. But we'll go ahead and do that since it was negative 1 on top in this case. Or if it's in front, it's all the same. It doesn't matter. Just pick one of the two. You're going to get the same answer. So 11 times 4 is 44. 1 times negative 1 is negative 1. Any number divided by 1 is 44, but a positive divided by a negative is negative. So our answer should be negative 44. Okay? Go try it. Let's go back. Delta math. Put in negative 44 and hope for the best. Submit answer. Oh my goodness, I am on fire. I should be, right? High school math teacher. Okay, here we go. All right, new problem. Here we go, new problem. Let's do it. All right. They're giving us some tough ones, huh? Okay, again, freeze it if you need to. Freezing it, we got about 15 minutes left. I think this is going good, this lesson here. Enjoying it. Hopefully you're getting something out of it.